Hello everyone. Today we are going to be talking about the mechanism of earthquakes, specifically on how earthquakes produce oscillations and applied to the use of a seismograph.
I'm sure many of you have experienced an earthquake at least once, but did you know that about 55 earthquakes are recorded each day across the globe?
To your right, you will see the aftermath of the earthquake that occurred in Nepal in 2015. This earthquake has caused 9,000 deaths with a magnitude of 7.8.
At the bottom, you will see a picture of a map from the largest earthquake recorded from southern Chile in 1960.
The earthquake was so large that it induced a tsunami that spread over 200 miles to the Philippines, Japan, and Hawaii.
In this presentation, we will be focusing on the topic of seismic waves. But what are they? These are waves of energy caused by the sudden impulse that goes through the Earth's layers. Commonly, they are produced by earthquakes and used to measure the strengths of them.
So there are two types of seismic waves, which are body and surface waves. Of the body waves, one example of them is primary waves. These are compressional waves that apply a push and pull force in the direction of the wave. As you can see in the animation, they are longitudinal in nature and push parallel to one another. They are also the fastest kind of seismic wave and are usually detected first.
Another example is secondary waves. These are shear waves that move up and down in the direction of the wave. In the animation, you will see that they are transverse as they move perpendicular to the motion of the wave. S waves are much slower than P waves and usually detected later. So, you may be wondering, how are earthquakes recorded? Well, they are recorded using an instrument called a seismograph.
To your left, you will see that a heavy weight will hang free while the base of the equipment remains secure. When an earthquake occurs and the ground shakes, the weight will stay still and result in something called a seismogram. These are the data recorded from the vibrations, which will act as oscillations.
But there are both benefits and disadvantages to this instrument. The advantages are the fact that they can measure and record the severity of the seismic waves. They also identify vibrations that can potentially help visualize the internal structure of the Earth. Finally, they help predict volcanic activity, as earthquakes sometimes accompany eruptions.
However, there are disadvantages in that the seismographs degrade over time and are sensitive to temperature, pressure fluctuations, and sound levels. Finally, the data taken from it is not a total displacement of the event.
We also wanted to touch on the fact that seismic waves are mechanical waves. They are oscillations that move through a medium and transfer energy but not matter.
So just like any oscillations, they will have frequencies and periods that can determine each earthquake type. High-frequency seismic waves indicate a jolting and short-term impulse produced from more destructive earthquakes. But low-frequency seismic waves indicate a tame and long-distance impulse, and they are usually produced from a smaller earthquake.
Wave amplitudes can also characterize the size of an earthquake. High amplitude waves indicate larger magnitude earthquakes, and low amplitude waves indicate a small magnitude one.
Finally, we wanted to share some modifications and applications of the seismograph. In modern days, these are being applied to investigate the structural performance of buildings during an earthquake. Using a shake table that simulates an earthquake will test the structure and its intensity with the seismograph.
Thank you so much for listening.
Hope you enjoyed it!